All right, hey guys, just give me a second to get my computer into split screen mode, and then we will get going on. Our topic is graphing logarithmic and exponential functions, all right? So let me get to the right screen. So you guys should have a worksheet that looks like this. It has your homework 6.7. It is not 6.7. This is chapter 8. Do not let that fool you. And it'll tell you to analyze the graph. It'll have a bunch of words. We aren't going to define them. I'll kind of just talk through them. So the domain and range, we've done this before, as you guys know, when we were talking about circles, parabolas, all of that. The domain is your set of all possible x values that the graph covers, not just all x values, because all x values go from negative infinity to infinity, but it's what the graph covers. And the range would then be your set of all y values. All right, those two are pretty simple. We've been doing them for a while now. Now, your new words are horizontal asymptotes and vertical asymptotes. Now, if you just hear me call them horizontal or vertical, that's because I hate the word asymptotes. It's so hard to say. Anyway, vertical asymptotes are where it never crosses your y, or let me start that again. It's where your y value is limited to. So, for example, you would write the equation y equals 5 if that's the horizontal asymptote. So it's your restrictions on your y values. Just as a heads up, you should be writing these down as I am typing them. So then vertical asymptotes, you guessed it, are going to be the restrictions on your x values. I don't know how to better explain that. Your end behaviors are going to be what your graph looks like as x goes to negative infinity or as it decreases, and as x goes to positive infinity as it increases. So you're going to write down your end behaviors. The definitions would be as x decreases / increases, what does y do? Okay, and then transformations, I'm not going to define that for you guys because you've seen transformations. We've been doing them for a while. You should have done them in probably pre-algebra, algebra, you know, all of those classes. It's just how your graph shifts. So what you guys are going to do is you are going to take your handy-dandy laptop, Chromebook, or desktop, whatever you're working on right now, and you are going to go to desmos.com. Remember that fun website we use to graph all of our circles and all of that? We're going to be using it again. You're going to go in and you are going to look at number 1. It says y is equal to 2 to the x plus 3 minus 1. Right? So we have to figure out what the parent function of that is in order to be able to figure out our transformations. In this case, our parent function is 2 to the x. All right? It's always just what is in front of your, oh man, how do I word this? You have your x value right here, right? It's just whatever goes right in front of there. So here we have the 2 right in front of there. So our parent would just be 2 to the x. For example, on number 2, you have the 4/3 right there. So it's just going to be your parent function is y is equal to 4/3 x. So we go in to Desmos and we type in y is equal to 2 to the x. And we get out this nice red graph right here. All right? It's very beautiful. It's very nice. It's very red. And I'm going to zoom out a little bit so you guys can see what's going on. And then in Desmos as well, you're going to select a new tab, and you are going to type in the function that we are looking at. So your y is equal to 2 to the x plus 3 minus 1. Notice here that I had it in parentheses because if you try to do 2 to the x and then plus 1, it is going to not do what you want. It's going to bring the plus 1 down. So you have to go parentheses x plus 1 and then close your parentheses and finish off with you, or sorry, it's supposed to be plus 3, and then close off with your minus 1. There you go. Never let a math teacher teach math because we never get our numbers right apparently. Then you're going to go in here and you're going to type in your transformations. Well, how did this blue graph transform from the red graph, right? So we go in and we see that it shifted down 1 unit and to the left 3 units. So that's what you write in your transformations. The next thing you're going to want to do is find your domain and range. Well, if you are zooming out and you're zooming out and you're zooming out, that blue, it's just going to keep on going forever and ever. For your range, or sorry, not range, range is y values. Whew, guys, it's been a long day. For your x values, it goes on from negative infinity to infinity. I cannot exactly type that in here, but you guys know what it looks like. You've got your parentheses like this, negative, and then it's a sideways 8, comma, to positive sideways 8, parentheses. All right, make sure you're writing your 8 sideways. I'm typing 8s. I cannot make them sideways. So then your range, you have to come over here and you have to look. Well, it looks like our range might be going on forever, but one thing you'll notice is that it flattens off. I wonder what that might be called, or what we might consider it. Could it possibly be a horizontal asymptote? So let's look at that value that it does that to. Now, if we're looking at it, it starts to flatten off around -1. I notice that it never goes below that line. Great. So we are going to put in our horizontal asymptote as y equals -1. Then our range, as you know, it never crosses that line, so it couldn't possibly go below that line. So what do you think? Our range goes from -1 to infinity. Now that should be a sideways 8. I'm just doing 8 so you guys know that it's the infinity symbol. All right, as you guys know, you can be pausing if I'm going too fast so you can catch up. Finally, we have to go through the end behavior. So as x decreases, what happens? Well, let's look. As x is decreasing, so your negative x value. Sorry guys, I keep pointing at my computer as if you can see what I'm doing. I'll remember to use my mouse. As x goes to negative values, it looks like y gets closer and closer to -1. But it never crosses -1. So it never equals -1. Next, as x increases, what does y do? Well, let's look. I'm trying to click on the blue equation. There we go. Now you might not realize it, but y is very slowly going on and on and on and on and on. Right? So it goes to infinity. And this is how we graph each exponential function. I would do an example of the log functions. I'm just going to do it really quick so you guys know what to type into the calculator. When you're going in, you don't need to do your log base 2 just because Desmos isn't going to let you do that, or at least I haven't found out a way for Desmos to let you do that. If you guys figure out a way, let me know. That'd be super cool to know. Let's see. Nope, not seeing anything. Oh, log base A, there we go. Perfect. So I'm assuming you guys didn't see what I did there, but you go under functions, and you go under miscellaneous, and then it's this little log with a little a on it, and then you can put in your number. Okay? So your parent function is going to be log base 2 of x, and your function that you're looking at is log base 2 of x plus 1 plus 2. Go into your transformations, your domain and range, your vertical asymptote and end behavior. Now, this is a very difficult topic because I know you guys have struggled with domain and range in the past. So please, please, please reach out to me if you need anything. And then also remember to give me a call if you need anything. I will be available from 9 to 3 on Google Hangouts, so you can definitely give me a call. You can shoot me an email, anything like that. Emily is also available all the time to help. We are team doing this. It's not been an easy process, especially because this is a tough topic. So thank you guys for hanging in with me, and good luck on this assignment.